Howdy. Today's topic is dot products. So let us look at some examples and then define dot product and then discuss some problems and application. So as a motivating example, let us discuss how to calculate work done by force in two cases. So for the first case, say we are applying some force F, horizontal force F, like this, to move this object along displacement vector, like this. So we have object on which you apply horizontal force, and then your object will move along the horizontal vector D. So two vectors share the same direction. So in this first case, it's not difficult to calculate the work, W1. Well, the work is a certain scalar, non-negative scalar. So for this work, we can take magnitude of F and then magnitude of D, and then you can simply take the product. The reason is, well, this work is proportional to both F and D. So proportional to both F and D. So that's why we can take this product to find the work. For the second case, here you're applying the work, you're applying force like this, and your object will move along displacement vector D, like this. So in this case, this force has different direction. So we have some angle between two. Say the angle is theta. So in the second case, we need to consider the actual force applied to the direction of this motion. So if you think of right triangle, then we will get a vector F prime. So essentially, only F prime is applied on this object to move along the displacement vector D. So that's why we need to consider this F prime. So for this, W2 is going to be magnitude of F prime and magnitude of D. Okay, let me rewrite quickly. So magnitude of F prime and magnitude of D, that's what we need.
You may want to move the W2 down also. Just do that last section.
So W2 is going to be magnitude of F prime and magnitude of D. Well, do you want to express this magnitude of F prime in terms of magnitude of F? Well, you can apply the trig function, especially the cosine theta. So cosine theta is the ratio between magnitude of F and magnitude of F prime. So F prime is magnitude of F times cosine theta, and then magnitude of D. So this is work, W2, done for this second case. So let us use this expression to define the dot product in the following slide. Okay, so from the previous calculation for the work, we want to define dot product. So we have force F and displacement vector D like this, the angle between them is theta. So in this case, the work was magnitude of F times cosine theta times magnitude of D. And let me reorder those terms to rewrite the work. So magnitude of F times cosine theta times magnitude of D, but let me put D first and then cosine theta. That is the work for this case, and that actually gives us the definition of dot product. So suppose you have two vectors like this, vector A and vector B, with angle theta between them. Then the dot product of those two vectors A and B is certain scalar or non-negative number. So the notation is A dot B, and then we are going to use this expression. So magnitude of one vector and magnitude of the other vector, and then cosine theta. That's it. That is the definition of the dot product. Well, whenever you have two vectors, you can think of the other angle theta prime. What if you use the other angle theta prime for this expression? Well, it turns out that two expressions are the same. So cosine theta and cosine theta prime are the same whenever the sum of two angles is 360. So that's why you can use the smaller angle. Okay, so again, whenever you have a pair of vectors like this with angle theta, the dot product is magnitude of A times magnitude of B, and then cosine theta. Theta is the angle between them. Okay. All right, so quick example of dot product. Suppose you are applying force F like this to move your object along this slope. So here vector D is the displacement vector. So in this case, you want to calculate the work. Well, you can draw some diagram to understand the situation. So we have horizontal vector F, and then displacement vector D like this. The angle between them is 30 in this problem. So we have two vectors D and F with an angle theta, 30. So we can use the dot product to calculate the work. So the work is going to be the dot product F dot D, and by definition, we take magnitude and then magnitude of D cosine 30. So in this problem, this force has magnitude 10 because it's 10 pound. And then displacement vector has magnitude 20 or 20 feet. And from the table of trig function, cosine 30 is square root 3 over 2. So after simplifying, we have 100 square root 3, and the unit is pound feet. Okay, that's it. So this is how to calculate the work when you have an angle 30 between two vectors.